relationship that can exist between classes, which is inheritance. We already kind of introduced the concept before. So the idea here is that if we have some classes that are very similar, they might have some attributes or methods that are common. So instead of repeating those common attributes or common methods in the same in two classes, like copy pasting, instead we try to put anything that is common. So common attributes plus common methods. We write them once in a class. We call that class a superclass. And then those common attributes and common methods get inherited by the subclasses. So instead of copy pasting those common, that's common code. So anyone can give us an example, and we take it from. We can discuss it through this. We discussed this before. Anyone can remind us of an example of inheritance? QU, which is
desktop and their students.
Okay, good.
They do have the same attributes.
Okay.
Like desktop, they have the name
Yeah.
and
Email
the
address.
email and the contact. And the students have as well, but there is some differences between them.
Yeah, okay, that's good. That's the idea basically. So what could be common? What can we name the class that has the common attributes and methods? Sorry? Parent. Yeah, that is a generic name. You can call it superclass or parent class. But still, remember, we always try to make our class name meaningful. So, for example, member or QU member or person, let's say member. Okay, we just make it member. We no need to make it QU member, because remember, sometimes a system we can build it for one institution and we can use it elsewhere. So better not to put the name of the institution in the class names. This is very important because many softwares start with an organization and they see it as a successful piece of software and they can generalize it. Okay, so here is the superclass member. And then we have the student class. And we have the faculty, or let's say faculty class. And now, what is the relationship between students and member? Inheritance, which means basically the student extends the member. So the UML notation for this is rectangle, empty one, and then we link it with the student. And same thing, the relationship between faculty and member. Faculty inherits from member, or another way to say it, faculty extends member. So this is an inheritance relationship. Inheritance relationship is also, we need to check that it is truly inheritance relationship by checking this is a property. Otherwise, it's not really inheritance. So can we ask ourselves, is a student a member? Yes, completely. Now, what about faculty? Faculty is a member. Okay. So, for example, like in the last class, some student told me they thought this is an example of inheritance. Let's check. So, for example, they mentioned like university and college. What type of relationship between these two classes? What is the relationship? This is more a composition. So don't let this one confuse you. This is nothing to do with inheritance. This is more a composition. So we'll put our diamond and we fill it. Why should we fill the diamond? Yeah. Yes. So it's a filled diamond, and this has a relationship. And not only has it's also a whole and part. This is the whole, this is the part relationship, and the part cannot exist without the whole. So this is the composition. It has nothing to do with inheritance. But even if somebody, by mistake, they thought that this is inheritance, they put the inheritance here, and they need to check it using is a. Now, is a college a university? No. So this is not inheritance. So always when you come up with this inheritance relationship, verify it. How do we verify that this is truly inheritance relationship? By asking the is a relationship. So composition has a relationship, while inheritance is a relationship. Okay, that's the idea. So the idea of inheritance is that we take the common attributes and the common methods, and we place them in one class. We call this class a superclass. Another name for superclass is parent class or base class. Don't let these terms confuse you. Some people might say to you base class or parent class. It's exactly the same meaning. Superclass, parent class, base class, all mean the same thing. This is the class where we put all the common attributes and methods. Now, once we do this, then we can create subclasses that inherit those attributes and methods. And the child class or the subclass, another name for it is child class and derived class. That's another name for this. Now, the subclass has access to all non-private members, non-private attributes and methods. What do I mean by non-private? It's basically, I mean by this, the public and the protected. If you recall the access modifiers, in Java, how many access modifiers we have? Four. We have public, private, default, and the protected. Okay. So the private, what's the rule of private? Only visible within the same class. And then we have the default, which means there is no keyword called default. It's just we don't put the modifier. In that case, what is the behave? Only visible within the package. Okay. Now, there is another modifier which is protected. Yes. So it's visible within the package and visible to subclasses wherever they might be. The subclass could be in the same package or outside the package. It's still visible to them. And then we have public, which is a member that is visible everywhere. Okay? So what I mean here, the subclass can access protected properties. Can the subclass access private attributes or private methods of the superclass? No. Only the protected ones. Of course, the public ones, everybody accesses them. بالأحرى يعني the subclass should be able to access them. Okay, so now in terms of now the subclass does not need to limit itself to the attributes and methods that are defined in the superclass. They can extend the superclass. When I say extend, it means two things. They can add new attributes or methods, or they can override or change the implementation or the behavior of the parent method. And this will become clear through an example. So extend means two things. The subclass can add attributes or methods. For example, the student class. What could be extra attributes compared to the member? The GPA as an extra attribute specific to student. What about the faculty? Extra attributes specific to them. Salary, or office number, and so on. Okay, that's the idea. Okay, now in terms of syntax, in terms of how do we write this in Java, very simple syntax. We create the class and we say extend and we put the subclass. Sorry, we put the subclass and we say extend and we put the superclass name. So if we do it here for students, if we create the class students, how we will create it in Java? So we'll do something like this. Public student. And then how do we make this student inherit from member? Extends, by using this keyword extends, and then the name of the superclass, which is member. And then we start defining our attributes and methods. Now, why inheritance is very important and we need to use it? What's the wisdom, or what is the rationale, or what is the justification of using it?
Reduce redundancy.
Reduce redundancy and code reuse. So we write these common attributes and methods once, and then we reuse them. Plus, we avoid using this copy pasting. So if we have some same code, we should never copy paste. Why is it not? It is important not to copy paste. Instead, use inheritance whenever possible. What is the?
If we wanted to change something in the code,
Okay.
we can change it once. We don't have to go to all of these.
Okay, very good. Excellent. This is very critical. Okay. In a large system, if you start copy pasting and if something needs to be changed, and remember, software is something like a living system. It can change. It does change. And we all know even operating systems, software that we use, we always have new changes. By the way, since the time we started this course, we started with, I think, with Java 12. Now we have Java 13. And by the end of the year, we will have Java 14. Every 6 months, they issue another version. So with extra functionality and so on. So we need to be careful not to do copy pasting, because copy pasting, if you need to change that code that you copy pasted it, you will pay the price. You have to look for it, where did you paste it, and change it there, change it in multiple places. And this creates, makes the maintenance or change. Maintenance means changing the code, either to fix some errors or to implement some new functionality or some new features. So those are the benefits. So first, we save time because we only need to develop common things once and then inherit them. We also reduce duplication, and this will ease maintenance. And this will allow us to avoid this copy pasting that creates a nightmare. So ideally, we should put the common things in one place. If we want to change them, we change them in one place. Now, in terms of limitations, in Java, a class can only inherit from another class. It cannot inherit from multiple classes, which is fine. This is one single inheritance is enough in most cases. But just be aware of this. You cannot inherit from multiple classes. You can only inherit from one class. So here is another example of inheritance. So I have, for example, a circle and a cylinder. And you can see here the circle, and the cylinder, they both have a radius. And let's say they both have a color. But the cylinder has extra attributes such as the height. Can you see here? This is an extra attribute, height. And also extra methods, get height and get volume. Get volume does not make sense for a circle, but it makes sense for the cylinder. Okay? So there are some common things, you put them in the circle, and then there are some extra things that we put in the cylinder. Here is another example of person that we'll try to do together. Maybe person is not the best name in this case. Maybe member is much better. And you can see there, these are the common attributes, which are the first name, last name. And then we have a constructor and toString, and of course getters and setters. All of those are common. And then we have student and instructor. Student has GPA as an extra attribute, and the instructor has office as an extra attribute. Okay, that's the idea. Okay, so let me just super quickly jump here and just do one simple example together. So let me just create a package. I'll create a package and I will call it inheritance sample. And I'll go ahead here and create a new class. Let's call it member. And this class will basically have int ID. I'll make it private. And then what I have here, string first name, and then string last name. Okay, so these are my attributes. And then I'll go ahead and generate my constructor. Here is my constructor generated. and then I'll generate the getters and setters. Okay, these are the setters and getters. So my class now is ready. It has these 3 attributes. Now for me to create, I'll go ahead and create another class which is student. Now how do I establish the relationship between the two? Make student inherits from member. All I do is say extends and then put member here. Yeah. Now, once I do this, I can start defining the attributes that are specific to students. So I'll say here private private GPA, which is of type float or double. Okay. And then I'll go ahead and create a constructor. So one way to do it, I can just click here and add a constructor. And you can see here, sorry, I think there is a little mistake here. Sorry, let me just remove this one. Let me create the constructor again. Yep. Okay, so don't worry about this one. So this is the constructor that will help us to initialize these 3 attributes. And then for student, I can go ahead and create a constructor also. Constructor from superclass. Okay, this is the constructor. Don't worry, let me just go slowly here. Then so basically we'll have ID, first name, last name, and the GPA, which is a float. So now this ID, first name, last name, they are defined where? Where did we define these attributes? In the super, yes, in the super class, in member. So I cannot because they were created as private attributes, I cannot access them, of course, from the subclass. Even if I try, for example, if I try to put here ID or this.id, it's not visible. This.first name. Now have a look at this get first name, for example, because it is public, it is visible. Let me show you. If I go here, how to make this one, if I want to make this one visible, by the way, this was visible, not visible, no, sorry. Private. I forgot to put private here. Now, how do I make, for example, ID visible to the subclass? Protected. Okay. Now, in the subclass, if I put ID, you can see here by the way, the way I can refer to the superclass by using this keyword super. So super, or sorry, just a second. I don't really need to. Just because the confused, so let me put. You see here ID. See, no complaints. ID. I can access ID because it is visible. Let me just put this one first name just to avoid the confusion. All right. Now, if I try to do the same for the first name, see here it's not visible. First name is not visible, although it belongs to the superclass. I cannot access it from the subclass because the modifier is private. If I want to really directly access it, I have to make it protected. Yes? Of course, I can get, yes, because it is child. Child, remember, that's the idea of inheritance. Child access all the non-private attributes of all the non-private attributes are accessible from the subclass. Yep. So of course I can also do something like this, set last name, and I can put here last name, yes. I can do here set, what else? ID, I already set it. Set, what else is there? First name, yes, thank you. First name, and this is the first name, yeah. This is one way of doing it. And of course, I can go here and say this.gpa equal GPA. This is initializing the...
You called it FM, not first name.
Yes, thank you. Okay. So this is one way of doing it, but this is not the best way of doing it. The best way of doing it is to reuse the constructor of the superclass. Remember, the superclass already has a constructor. So how can I reuse, instead of reinitializing this stuff myself, how can I reuse the superclass constructor? Remember, this class already has a constructor, and this constructor is able to initialize all these attributes. So I should not repeat this logic in the subclass. But at the same time, I cannot directly call, it's not a method I can call. It's not like set first name or set last name. I cannot call it directly. Instead, there is a special keyword that allows me to do this, which is super, and then I pass in in this case, the student's ID, the first name, the last name, okay? And that's it. Now in here, what I can do also, generates the getter. I just want to generate get. Here's the get, yeah? That's it, this is the idea. So here I have a constructor of the subclass, and this constructor is reusing the constructor in the superclass. How do I reuse the constructor of the superclass? By calling this, by using this special keyword super, and I pass in the initializer, the parameters to this to the superclass constructor. In this way, the superclass will take care of initializing these common attributes. Yep, that's basically the idea. I can do the same for faculty, so I can say public class faculty extends member, and then I will have, let's say, string office number, and then I can do exactly the same here. Yeah, that's the idea. So the subclass extends the superclass, inherits all the attributes and methods, and can also access the protected attributes and methods, and also it can access the public attributes and methods. And not only this, I can reuse the constructor of the superclass by using super followed by the parameter names to initialize the attributes that belongs to the superclass. Is clear?